Today, my topic is on CSIR net and WB set. This is very important topics. I think this class is highly helpful to all of the students who are appearing set and net exam. This is very important topics. First, come to the topic, that is properties of an ideal opamp. So there are so many properties. I mentioned some of the importance. There are some important properties. Number one, that is open loop gain is infinite. Number two, open loop bandwidth is infinite. Number three, common mode rejection ratio, that is CMRR, is infinite. Number four, input resistance is infinite. Number five, slew rate should tend to be infinite. Number six, that is output resistance is 0. Number seven, offset voltage and current are 0. And number eight, perfect balance, that is output is 0 when V1 equal to V2. So when inverting voltage and non-inverting voltage are equal, then output is 0. So these are the main features of the ideal opamp. So opamp parameters. So there are input, number one, that is input offset voltage. Input offset voltage, an ideal opamp is perfectly balanced when V1 and V2 equal, that is V0 equal to 0. That is when the input voltage are equal and output voltage, that is 0, then we get, that is input offset voltage. So in language, when both inputs of opamp are grounded, there almost is an voltage, this called, that is output offset voltage. The input offset voltage is difference of input voltage. So input offset voltage is the difference of the input voltage, and input voltage is amplified to produce an output offset voltage. A finite non-zero output voltage appears at the output of an opamp when there is no applied input signal. So this is the circuit diagram. RF, that is feedback resistance. This is the input offset voltage. So this is output voltage. So the non-zero voltage of an opamp can be balanced by applying a small DC voltage between two terminals of opamp. This DC voltage is known as the offset voltage of opamp. So this is the definition of input offset voltage. Voltage of an opamp can be balanced by applying a small DC voltage between two input terminals of opamp. This DC voltage is called, that is input offset voltage of opamp. So input offset voltage of the circuit we calculated, that is VIO, that is R1 by R1 plus RF into V01. So this is the output voltage of opamp. So if I know, that is R1 and RF and also the output voltage, we can easily calculate, that is the input offset voltage. So after knowing this value, we can easily calculate that is input offset voltage. Next we come to the input offset current. Input offset current, we know that is plus, this is the non-inverting terminal, minus, that is inverting terminal. Input to non-inverting terminal is, that is V1. V1 we can say that is IB1 into RB. V2, that is non-inverting terminal, that is IB2 into RB. So we can write this is the IB1. So this is the IB1, this is the IB2 that is flowing through the resistance in the ground. This is the IB1 and this is the IB2. This is RB, this is RB. So differential input voltage we can write that is V1 minus V2. So we get that is V1 minus V2 equal to IB1 minus IB2 RB. We can write. So IB1 and IB2 are the bias current that flow through ground through the bias resistance. IB1 and IB2 are the bias current that flow through ground through bias resistance. Input offset current. So input offset current, that is IIO, that is IB1 minus IB2, we have known in the previous explanation. So we can write that is IIO equal to IB1 minus IB2. So it is defined as the difference between the two bias current that flow to ground through the bias resistance. So input bias current we can write that is IIB. We can write that is IIB equal to that is IB1 plus IB2 by 2. So input bias current is the average current. So it is defined as the average of two separate currents flowing through ground through the bias resistance. So we can write that is IB1 equal to IB plus minus IIO by 2. Similarly, we can write that is IB2. This is the concept of the input offset current. Again, we have known that is closed loop gain. Closed loop gain, we have known that is closed loop gain. Closed loop gain, this is circuit, this is output voltage, this is input signal, this is feedback resistance, this is input resistance. So voltage gain with feedback network is known as the closed loop gain. So voltage loop gain with the feedback resistance but feedback network is known as the closed loop gain of the amplifier. Closed loop gain of inverting op-amp is, that is V0 by Vs equal to Rf by R1, and similarly we can write that is open loop gain, the voltage gain of an op-amp without feedback network is known as the open loop gain. Its value order of 10 to the power 5. Again, we have to know that is the virtual ground. This is very important for the NET set exam, and this is the virtual ground concept. So this is the terminal A, this is Vi input voltage, this is signal applied, this is the output voltage V0. So Vi is the potential at A, so here signal is given Vs. So in this point A, that is potential Vi. That is Vi is the voltage at the inverting terminal. This is the minus represent that is inverting terminal. So in this point, that is Vi is the potential. So in the case of inverting op-amp, open loop gain, that is infinite. We know from the definition. So we can write that is AV mod equal to V0 by Vi. Here that is AV infinite. So we can write that is Vi equal to 0. So Vi 0. Further we conclude, further we know that is input resistance, the condition of op-amp, that is the properties of op-amp, input resistance that is infinite. From this concept, that is Ri tends to infinite. So no current enters in the op-amp, no current enter op-amp input terminals. So hence the inverting input terminal is practically at the ground potential. That is, this potential is virtual ground. Hence there is no current flowing through the terminal. So this terminal is known as the virtual ground, since it is not actually connected to ground. Virtual ground means a point that is at A used to imply this point is effectively connected to the ground. No current flows in this terminal. Significance of there is an important significance of virtual grounds. So significance, the concept of virtual ground makes analyze and understanding many op-amp circuit easily. So from this concept we can easily calculate difference op-amp circuit very easily. This is the main concept. If I do not take the consideration the concept of the virtual ground, then the analysis will be very tough. So this concept make the circuit very easier and very useful way. I think this is very helpful for honors level and pass level and also CSIR NET exam. Next, difference between virtual ground and actual ground. An actual ground can serve as a sink of any current. A virtual ground does not do so because no current can flow through it into the op-amp having infinite input impedance, that is resistance. So we have to first remember why op-amp is called so. Amplifier is basically a direct coupled high gain differential input amplifier. It is termed operational because it can perform mathematical operations, that is summation, integration, differentiation, etc. Next, we have to know that is input output characteristics of opamp. So this is the x-axis. If I plot x-axis along input and y-axis along output, so we get the graph. This graph is known as the input output characteristic of opamp. Numericals: a certain opamp has bias current 50 microampere and 49.3 microampere. Find the input offset current in nanometer. I know the concept of input offset current, this equation. So putting the value, we get 0.7 microampere. So we know that is microampere means that is 10 to the power minus 6 ampere. So we can write in this format, so 700 nanometer. I think this class is highly helpful. All students are requested to watch the video fully. This is highly helpful for pass level students, honors level, and extremely helpful for CSIR NET and WB set or any competitive exam. So please like, share and subscribe my channel. I requested to all of my friends and all of my dear students, please share the link of the channel to your friends and like the my each video, so that we get motivated in each video, in making each video. Thank you all my dear students.